In this video, I am going to show you with several examples the process of adding vectors graphically. So now we'll use different colors to indicate different vectors. So say the following is true. You have a vector, which of course is just represented using an arrow, that looks this way. And say there's another one floating out somewhere that looks like this. Okay. Let me thicken the stems so they look a little easier to see. There we are. So these are our vectors. Now the question is, how do we add these vectors graphically so as to obtain the resultant or the sum? Okay? Or that one vector that has the same effect as these two individual vectors put together. So we use the law of parallelogram, parallelograms, or the parallelogram law for vector addition. So let's take a look at what this looks like in practice. What we will do is this. We will take this vector from here and we will shift it down and add it to the tip of this one, keeping the length and the direction unchanged. So we are taking the orange one and shifting it and placing it at the tip of this one, keeping the direction and the length unchanged. So the length of this one is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So it looks like this. Once you've done this, then you connect the beginning of the light blue with the orange tip. And what results, the one I've just drawn, is the resultant vector. It's the vector that has the same effect as the two other vectors put together. Okay. Now, the next example will be within the confines of a coordinate system. So let me draw coordinate axes, a y-axis and an x-axis. As follows and as follows. This is y, this is x. Okay, these are our coordinate axes. Now, say we have the following. We have one vector along the x-axis, the blue one, and another one, the orange one, along the y-axis. What we're going to do is add them. So the way to do it is you take the orange, you move it, and you place it at the tip of the blue, keeping the direction and the length unchanged. As follows. And once you've done this, you connect to indicate the resultant with a line, with an arrow. There we are. So the blue light one is the resultant of adding the dark blue and the orange one together. Okay, so let's label them a little. Say we call this one A. Say we call this one B. In the light blue, we could call A plus B. And here it's also common to mark these up further by having little arrows above the letters to indicate that these are vectors. Okay? Let's try another example within a coordinate system. So once again, we have an x-axis and a y-axis. Say this time we have vectors that look like this. There's this one here, and then there's this one here. And we want to add these pictorially using pictures, using the parallelogram law for vector addition. So let's take a look at what we have. We will take the blue one and shift it to the tip of the orange one. So it looks like this. And then we connect those two with a dark blue one to indicate the resultant. Okay, so let's label them to be sure everything is as it should be. We'll call the orange one A We'll call the light blue one B. We'll also call this one B here because it's same vector shifted over. Okay, so B. And then the dark blue one is A plus B. Okay. Now the key point is this: you don't have to add them in any specified orders. So I chose to take the B and shift it to the tip of the orange one. I could easily have taken the orange and moved it to the tip of the blue one. So had I done that, take a look. A parallelogram would actually have occurred, right? Would actually have appeared, as it has in this case. Not perfect, but strongly suggestive of what a parallelogram actually, might look like. In either case, what you have is a resultant that is the same. So it doesn't matter whether you take the blue, move it to the tip of the orange, or you take the orange and move it to the tip of the blue. The resultant is the same in either case. And you might ask why that is so. Well, let's refresh our knowledge of the fact that 4 plus 5 is the same as 5 plus 4. This is 9, and this is 9. So in another video, I will look at the mathematical details of vector addition. Here we're concerned primarily with the graphical method of vector addition. Let's take a look at another example, just to be sure we know what is actually occurring here. And in this one, we will add 3 vectors together. Okay, so there's our xy system, coordinate system. This will be the x, this will be the y. We draw 2 perpendicular lines, of course, that meet at 90 degrees, the origin. Say one lies along the x. There's a blue one that lies that way. That's a light blue one. And say we have a dark purple one along the y-axis over here. Okay, so you have 3 vectors we're going to add together so as to find the resultant or the sum. So what we'll do is this. You'll take the blue one and move it to the tip of the orange one, keeping the direction and the magnitude or the length unchanged. So it looks like this. Then we take the purple one and place it at the tip of the blue one. So roughly it looks like this. Now that we have these arranged as in the picture here, we connect with the resultant vector. So that looks like this. Okay, there you go. So the red one here is the following: A plus B plus C. Okay, the red one is the addition of the orange, the blue, and the purple. So let's label the original vectors also so we know which one is which. So the orange one we can take as A, the blue one we can take as B, and the purplish one we can take as C. So now we have A plus B plus C. And the result is this vector right here. Yes, remember, a vector is a directed line segment. Oftentimes they represent various physical quantities such as forces. And when you add them as I've shown you in these several examples here. And at times you might use what is known as the parallelogram law for adding vectors, which actually looks like this. And keep in mind that because ultimately all you are doing is operating on numerical values, it does not matter whether you do A plus B or B plus A, the result is the same. Thank you for watching.